In this video, I'm going to talk about doing analysis for one-dimensional line models. First, we need to create a mesh that is the finite element model. Then we apply boundary conditions and laws. After that, we solve the model. And finally, we do post-processing to get the output of the results. So after we created the geometry, we go to model and we can see a pair of green arrows. Means we need to update the model. Just right click to update. Now we can double click to open ANSYS Mechanical. So we can see a few buttons here, and this to adjust the view, and those will be like filters for like selecting points, lines, and faces and bodies. Now this is to fit into the screen, and some use for like function is you can also reset the layout here, and if we go to geometry, we can see the stepped shaft with two line bodies, and we can also adjust this window here, and down here we can see the properties or attributes for the line body, and the definition. And first to look at the model type. By default, this is a beam, and which also works, but with better to change from beams to link or truss. And now move on, we can see cross section is circular one, and behavior now is tension and compression, so axial only. And if we change to beam, we can not see such option, so link and truss. And for the material, that should be the steel we created. Now the next line body also should be link or truss, and also steel. Now move on to mesh. So by default, we can see many elements on those two lines. And if we just want one element per line, we can just insert like the sizing, control the size. So for geometry, we click on this button to select edges, and right click in this area to select all. Now it says two edges. So definition, we change from element size to number of divisions. So one division per line. Now go back to mesh and right click generate mesh. Now if we go to display, we can see the cross section. The cross section is for the geometry. So we can see the geometry. If we go to the mesh, we need to see thick shells and the beams like that. Now go to static structural to apply boundary conditions. And we could either right click to insert like a fixed support here, or like go to this graphical area and change to vertex and pick up the vertex on the left and right click insert fixed support there, and then go to the other end, right click to insert a force. So for the force, change from vector to components. 132 kilonewtons. Now we define the boundary conditions and loads. Then we can solve the model. Before doing that, we insert like the results we want. So directional deformation in x direction. So we can see like either all bodies or like we select like change to edge, like the first line body, and create another one, and the second line body. And go to solution, insert probe for force reaction due to fixed support. And now we can solve the model. So we can see the directional deformation for each of the lines and also the reaction force given in here. Now we are going to attach a spring to the right end of the stepped shaft. To do that, we go to like connections, like connections here, and we can see spring. So this is a body to ground. So body will be like the right end of the shaft, and the ground will be some fixed point, like away from the component. And the spring constant will be 2000 Newton per millimeter, or 2000 kilonewtons per meter. And reference point will be the ground. Let's put 1.2, oh, in millimeters, so 1200. And we can also change the units from millimeters to meters. And so mobile means the that body, like ground to body. And we can select that vertex So now, because we set reference to be 1.2 meters, and the spring length is 0.4 in meters. And we can right click to insert probe spring. And the longitudinal ground to so ground to, we can right click here and rename based on definition. So ground to line body. And then we can solve. Now we should see some different, we can change to millimeters. So millimeter ton, newtons, this one. And see some different values for deformation and reaction force, and here also spring force. So these two bodies can have different materials. So for example, the first one can be changed to aluminum, and we can solve again. So we can see the new deformations. And after that, we can close the ANSYS Mechanical and save the project and maybe create an archive. Okay, I'll stop here.